there! You might be wondering what this video is about. Don't fret, that would be answered shortly. Are you curious learners as well? Let's dive into the process of DNA replication for eukaryotes. The cell is the basic unit of life, according to Schwann and Schleiden. Composed of essential building blocks like genetic information such as deoxyribonucleic acid or DNA are located inside the nucleus of eukaryotic cells. Each having its own pair, like adenine, is bonded to thymine, and cytosine is bonded with guanine, and vice versa. These nucleotides are important for their composition of sugar, phosphate, and nitrogen bases, allows this structure to do its role in replication. Cell cycle, the process where cell division occurs, but on a molecular level, DNA replication is happening behind the scene. Just like breathing or even blinking, it happens continuously and naturally. We have the gap 1 or G1 phase where the cell division occurs, stationary phase or S phase. This is where DNA replication occurs. We know that DNA strands always begin with 5' and end with 3'. The reason behind this is that the OH found on the 3' end can easily pair with the phosphate of the nucleotides of the newly synthesized RNA strand, starting from the 5' and with the help of the phosphodiesterase enzyme. As initiation starts with pre-replication protein complex or PRPC, an indicator that replication has truly begun is when the promoter will make contact under the first stage of initiation. In the origin of replication, it is composed of adenine and thymine as they are hydrogen bonds. And it can be broken down easily because it has only 2 hydrogen bonds as compared to cytosine and guanine that has 3 hydrogen bonds. Now, as the DNA helicase comes in, it helps in unwinding these strands. As the DNA helicase continues to do its role, we can see the formation of the replication fork. As the elongation happens, there's a tendency for the DNA to supercoil as the stress accumulates. To prevent supercoiling to occur, the topoisomerase will come in to help prevent annealing. There are 2 things happening here. First, we see that the nuclease is cutting the strands, whereas the ligase, on the other hand, is connecting these disconnected strands seen from the 3' to the 5' end. As DNA strands are separated, single-strand binding proteins or SSBPs bind to the single-stranded DNA, preventing the reformation of hydrogen bonds and keeping the strands from reannealing. Next, RNA Primase adds short RNA primers in the 5' to 3' direction on the leading strand, providing the necessary starting point for DNA polymerase to begin synthesis. On the lagging strand, RNA Primase adds primers as well, but in small, fragmented pieces. This is because the direction of synthesis is opposite to the reading direction of the DNA. Now, DNA Polymerase III comes in to synthesize the leading strand from the primer in a 5' to 3' direction. The SSBPs are removed once the polymerase passes them. DNA Polymerase III also works on the lagging strand, synthesizing in the 5' to 3' direction between the primers. This results in the formation of the Okazaki fragments due to the 3' to 5' reading direction. After synthesis, nuclease comes in to remove the RNA primers from both the leading and lagging strands, clearing the path for the next step. DNA Polymerase I takes over, replacing the removed RNA primers with the correct DNA nucleotides on both strands. The remaining Single-strand binding proteins are also removed as the polymerase finishes the job. Finally, ligase, aided by topoisomerase, seals the phosphate backbone of the Okazaki fragments, connecting them together. This process ensures both strands are properly linked, completing the replication process. It's important to note that the two DNA strands are semi-conservative. This means that while one strand preserves the old information, the other half is newly synthesized. And with that, the process of DNA replication is complete, ensuring that each new cell gets an exact copy of the genetic material. That is everything you have to know about DNA replication, presented to you by Group 1. Thanks for watching, and we hope you learned something from us.
I used to cop a lot, but never cop no drop. Hold mics like ponytails tight and bobble ops. Stop, stick around, come through and dig the sound of the fly brown 6060 psycho who throws a dick around. Bound to go 3 plat, came to destroy rap. It's an intricate plot of a b-boy strap. Fem stack cats get kidnapped. Then release a statement to the press, let the rest know who did that. Metal fist terrorists, claim responsibility. Broken household name usually set in hostility. What is MF, you silly? I like to take men's to the end for 2 milli. Do-do-do-do-do, that's an audio daily double. Rappers need to fall off just to save me the trouble. Yo, watch your own back, came in and go out alone, black. Stay in the zone, turn H2O to cognac. On doomsday, ever since the womb till I'm back where my brother went, that's what my tumor say. Right above my government doomulate, either unmarked or engraved, hey, who's to say? I wrote this one in BCDCO section. If you don't believe me, go get bagged and checked in. Cell number 17 up under the top bunk. I say this not to be mean, was bad luck a pop junk. Pop the trunk on C-Cypher-Punk, leave him left scraped, God forbid. If ain't no escape, blame MF tape. Definition super villain, a killer who loved children, one who is well skilled in destruction as well as building. While Sidney Sheldon teaches the trife to be trifer, I'm trading science fiction with my man, a live lifer. A Pied Piper, holler a rhyme, a dollar and a dime, do his thing, ring around the white collar crime. Get out my face, asking about my case, need toothpaste, refreshment, monkey style nigga.